So I hope the screen is visible.
Yes, sir.
Yeah.
Yes, sir.
So linear differential equation So a linear differential equation is of the form an d raised to n y upon dx raised to n plus an minus 1 d raised to n minus 1 y upon dx raised to n minus 1 plus dot 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 up to a1 dy by dx plus a naught is equal to 0, or say f of x. I'll write it at 0, where an minus 1 dot 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 till a1 comma a naught are constants. Okay, so there are two things I want to explain with this. What is the order of your differential equation? What do you mean by an order of a differential equation? How many times you take a derivative? Like in this term, if you see, what do you have? D n y by dx raised to n. What do I mean by this? This is n derivatives of y. So d by dx of dn minus 1y by dx raised to n minus 1, which is also equal to 2 times derivative of dn minus 2 of y upon dx raised to n minus 2. So you're taking n number of derivatives. So this is n number of derivatives. This is n minus 1 number of derivatives of y. So on, it will go on decreasing up to one derivative of y, and this term a naught y, this will be no derivative of y, is equal to a function. So nth order linear differential equation. One more thing, this an minus 1 up to a1 a naught, these I have already written that those are constants. So nth order linear differential equation with constant coefficient, with constant coefficient coefficient is of the form this, where n and these are constants. So this is the definition of nth order linear differential equation with constant coefficients. I want you to write it down in your register.
So whole we have to write from the nth order starting.
Yes, yes. So each word is very important in this definition. What do you mean by nth order? What are the coefficients? And this is the form. Done. So let me go ahead now. So what I will do, I will write d by dx as capital D. Okay. So once I write d by dx as capital D, now my differential equation will be changed. So what do I get? An. So d raised to n is there. So this will be capital D raised to n y plus an minus 1 d raised to n minus 1 y plus dot 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 up to a1 capital D plus a naught capital dy plus a naught y is equal to f of x. So in this case what I can do is I can take y common. So in bracket what do I get? An d raised to n plus an minus 1 d raised to n minus 1 plus up to a1 d plus a naught bracket complete y is equal to f of x. Can anyone tell me what is this bracketed term? Anyone, what is that bracketed term? Derivative. No. So this is a polynomial. So as you can recall, en x raised to n plus en minus 1 x raised to n minus 1 up to a1 into x plus a naught. So this kind of polynomial we have seen yesterday, not yesterday, in the previous lecture. So in the place of variable d, there you had x. So this is a polynomial in terms of d. Okay, so that is the reason why I have recalled polynomials before we go to linear differential equation. Okay, so I'll just mention it over here. Polynomial in d. So d is the variable in this case. Fine. So we will see what we have to do with this polynomial later on. Before that, we will talk about classification of this linear differential equation. So we have seen that a linear differential equation now looks like an d raised to n plus an minus 1 d raised to n minus 1 plus up to a1 d plus a naught y is equal to f of x. So just now we have seen that I can write this differential equation in this form, which in a simplified form can also be written as phi of d acting on y is equal to f of x. What do I mean by phi of d? Phi of d is actually the notation for a function or in terms of d. So what is this? A n d raised to n, a n minus 1, d raised to n minus 1, and so on up to a naught. This is a function of d. So that's why I can write it down as phi of d. So every differential, this is a linear differential equation with constant coefficients. So further this, whenever I want to address a linear differential equation, a general one, I will start from phi of d acting on y is equal to f of x. Now, so there are two types of linear differential equations. First one, homogeneous. Homogeneous linear differential equation if in phi of d acting on y is equal to f of x is equal to 0. Then the linear differential equation is homogeneous. That is, so this is called homogeneous. Non-homogeneous linear differential equation. If f of x is not equal to 0, then phi of d acting on y is equal to f of x. Is called non-homogeneous linear differential equation. Okay, so there are two types. Linear differential equation is of the form phi of d acting on y is equal to f of x. Look, I am using word acting because this is an operator phi of d. Okay, so phi of d acting on y is equal to f of x. So if f of x is 0, then my linear differential equation is homogeneous. If f of x is not equal to 0, then my linear differential equation is non-homogeneous. So we will see some of the examples of linear differential equations. and then we'll go to the next thing. So examples. First one, d2y by dx square plus 3 times dy by dx plus 5 times y is equal to e to the power 2x. Anyone, what is the degree of this? Order of this?
2.
2.
Two.
Order of this differential equation is 2. Is it homogeneous? Is it homogeneous? Is it homogeneous?
No.
No. So I can see that the right hand side is not equal to 0. So it is non-homogeneous. Now we'll reduce it to our form. Phi of d acting on y is equal to f of x. So what I have to do? I have to write down d by dx as d. So this will be d square y plus 3 dy plus 5y is equal to e to the power 2x, which gives me d square plus 3d plus 5y is equal to e to the power 2x. Next one, d raised to 3 by 2 y upon dx raised to 3 by 2 plus y is equal to 0. Yes, anyone? Linear?
Yes,
Yes, sir.
sir.
It's linear.
It's linear. Why do you think so?
It's homogeneous. Linear तो है ही.
Linear है.
Homogeneous
Sir, can I explain the step again? The second one,
Which
d upon 3 by 2.
it is no, it is just a question. There's nothing to explain in it.
Okay.
We just have to identify whether it is a linear differential equation or not. So I'm
Yes,
going.
sir, because it's having 0.
Let it be. No problem at all.
Okay.
Okay. So what I am trying to, point out here is, if you look at the difference in the previous one, you had power as an integer, say not integer, say natural number or whole number. But in this case, if you look at the power, that is 3 by 2. How do you take derivative 3 by 2? I mean, one and half derivative of something. Does it make sense? No. So the point is, of course, there are derivatives of this kind, but let's not get into it. What we need is, in a differential equation, order has to be a natural number. Order needs to be a natural number in our syllabus. Okay, natural number. Make this clear. Okay, so I won't consider this. Of course, it is homogeneous because the right hand side is 0. So third one, d cube y by dx cube minus 3 d2y by dx square plus 1 plus y is equal to 0. So yes, it is linear. Moreover, it is homogeneous. Homogeneous linear differential equation of order degree. Order is 3. What are the coefficients? Coefficients are constant. Here it is 1, here it is 3, and here it is again 1. So with constant coefficients, I can say that. Look, I am pointing out coefficients differently because we will later see where coefficients are variable. Like at the place of 1, you will get x square or x cube. At the place of 3, you will get x square. So in that case, our coefficients will be variable. Right now, I am concentrating on linear differential equations with constant coefficient. Okay, so let's just try to convert it to this form. Anyone, pi of dy is equal to 0. I need my differential equation in that form.
Sir, d cube y minus
Hmm.
3d square whole bracket into y.
Square plus 1 bracket complete y is equal to 0. Very good. So this form will help me to find out the solution of any differential equation. So you must be very comfortable with writing it down in this form. Okay. So yeah, if you have written the examples, I can go ahead. So solution of a differential equation. Phi of d y is equal to f of x. Anyone, do you remember from your M1, M2, M3 of your diploma? What is solution? Or if you have read it, what is solution of a differential equation? The function, or in rough words, I will write down the value of y. Value of y satisfying satisfying the differential equation. The differential equation phi of d acting on y is equal to f of x is the solution of differential equation. Differential equation. Okay. So what I'm saying is, when you say you want to find a solution of a differential equation, what do I actually need to find is the value of y. So you find this y in such a way that if you put that y on the left hand side and you solve that left hand side, you will get the function f of x. Okay, that is the complete idea. For an example, I'll simply write down an example for a better understanding. Say I will write down d2y by dx square plus y is equal to 0. Okay. Now take y is equal to sin x is the solution. Is the solution. This is my claim. You need to check it. So what I need to do is I need to put this y is equal to sin x on the left hand side, and I will see whether I get the right hand side or not. So d2 by dx square in bracket sin x plus sin x. This is my LHS. Now let's take 2 times derivative d by dx in bracket d by dx of sin x plus sin x. So derivative of sin x is cos x. So d by dx in bracket cos x plus sin x. Now you take the derivative of cos x, which is minus sin x plus sin x. These two will cancel out each other, and the answer is 0, which is equal to RHS. So is it clear what thing do you call a solution? So
Yes.
solution is simply the value of y which will satisfy your differential equation. Now there are different type of solutions. Like on a rough page, I would like to tell you, check whether y is equal to cos x is a solution or not. Check it. On a rough page, check it whether y is equal to cos x is also a solution or not. Yes, Janvi, is cos x a solution or not? Raj Bora, is cos x a
Yes.
solution? Yes or
Yes,
no?
sir.
cos x solution है?
Mm, no,
No,
sir.
sir.
No.
Sir, 2 cos x आ रहा है.
Shaunak. Is it Shaunak?
Yes, sir.
Okay. 2 cos x नहीं आना चाहिए.
Sir, minus sin x का डेरिवेटिव प्लस cos x, मतलब cos x plus cos x आ रहा है.
नहीं ना, माइनस साइन एक्स का डेरिवेटिव माइनस कॉस एक्स आएगा.
Okay, so then yes, it's coming.
Yes, sir, it is solution.
Okay. So cos x is also a solution. Moreover, I will tell you now, you can also check this. Say y is equal to sin x plus cos x. This will also turn out to be solution. With this, y is equal to 3 times sin x plus 3 times cos x. This will also be a solution. I can take 100 times sin x, 200 times cos x. That will also turn out to be solution. It means that I am missing something. I mean, there are infinitely many solutions for this differential equation, and that is true for any differential equation. Like you take a differential equation, it may happen that there are if it has a solution, then there will be infinitely many. Okay. So what I want to do is I want to make a concrete form in which a solution will appear. Okay. So there are two types of solutions. One is general solution and the other is particular solution. So these things you are also going to see in your bridge course, because these are first year things that I'm taking it because I need it. So this is a general solution. Okay. So if you look at the previous example, y is equal to a sin x plus b cos x. Okay. So all the solutions that I wrote earlier, say y is equal to sin x, y is equal to cos x, y is equal to sin x plus cos x. So you give different values to this a and b and you will get different solutions. If you put a is equal to 1 and b is equal to 0, you will get the sin x. You put a is equal to 0 and b is equal to 1, you will get this solution cos x. If you put a is equal to 1, b is equal to 1, you will get this. You put a is equal to 3, b is equal to 5. So you will get y is equal to 3 sin x plus 5 cos x. And let me tell you, this will also turn out to be the solution. Okay, so you can give different values to this a and b and you will get different solutions. Okay, so what is the general solution? A general solution is the solution with these a and b are constants, with number of constants equal to the order of differential equation. So such a solution is called general. So let's write down the definition. If in a solution number of constants not just constants, arbitrary constants, number of arbitrary constants is equal to order of differential equation. Then the solution is general. I will write down a example here. Y is equal to a sin x plus b cos x, b cos x is the general solution for d2y by dx square plus y is equal to 0. So I can see that order of this differential equation is 2, and in this y I can see that a and b, there are two arbitrary constants. So this solution is general. This is the basic definition of general solution. In our linear differential equation, I will reframe this thing and I will write it down in a different manner. But of course, the concept will be same. Arbitrary constants equal to the order of differential equation. So if you are done, I can go ahead. So for a linear differential equation, we will need two types of solution. The first one is the auxiliary solution. Some people also call it characteristic solution. This solution is denoted by auxiliary solution is denoted by is denoted by YC and is found using the roots of auxiliary equation. Auxiliary equation. So now the clear question arises, what do you mean by an auxiliary equation? So I will quickly make a remark here. For a linear differential equation, it looks like phi of d acting on y is equal to f of x the auxiliary equation is auxiliary equation is phi of d equal to 0. So for this we will need calci now. So you have a differential equation. I can write it down in this form. We have already seen how do you write it down in this form. So once we get to this form, later what I have to do is I will just take the thing which is in the bracket with y, equate it to 0. That equation is called the auxiliary equation. Okay. And using this roots of this auxiliary equation, I write down a solution, which solution is called the auxiliary solution, and it is denoted by YC. Particular solution particular solution of a linear differential equation phi of d acting on y is equal to f of x is denoted by is denoted by yp and can be found using f of x. ओके सो पर्टिकुलर सॉल्यूशन हमें कैसे फाइंड करना है राइट हैंड साइड यूज करके लुक आवर बेसिक डिफरेंशियल इक्वेशन इज दिस सो फॉर अ लीनियर डिफरेंशियल इक्वेशन ऑफ दिस फॉर्म तो पहले मैं yc फाइंड करूंगा yc कैन बी फाउंड यूजिंग phi of d equal to 0 ओके सो आई विल सॉल्व दिस एंड आई कैन फाइंड आउट yc तो ये यूज करके मुझे yc मिलेगा and then I have to use this right hand side f of x to find yp. So for any linear differential equation, I will need two things, yc, that is auxiliary solution, complementary solution, characteristic solution, whatever. And other thing I'll need is the particular solution. Auxiliary solution can be found using the auxiliary equation, which is phi of d equal to 0. And particular solution I will be finding out using the right hand side f of x. Okay, so I will write down the last definition and then I will stop, and the definition is general solution. So general solution, more than a definition, this is a remark. General solution of a linear differential equation of nth order with constant coefficient with constant coefficients is given by is given by y is equal to yc plus yp. What was our differential equation? Phi of d acting on y is equal to f of x. इसका सॉल्यूशन कैसे दिखेगा? yc plus yp का. Okay, is it clear whatever we have done today?
Yes, sir.
Yeah. So in tomorrow's lecture, I will start with auxiliary solutions. Before I conclude, can you tell me yp for homogeneous solutions? For homogeneous linear differential equations, sorry.
0.
Differential equations is 0. What do you say homogeneous? Is right hand side is 0. we have seen that our particular solution yp needs to be found out using your right hand side. और अगर homogeneous में right hand side 0 ही है तो yp needs to be 0. Fine. So here we will stop. Let me just download your attendance.